Hello guys and welcome to a new episode. As I told you a few weeks ago, I worked for a television series in late December 2018. In that series, I'm part of a team of people who repair stuff in front of the camera. The first season of 10 episodes will launch later this year. At this point in time, I cannot tell you when exactly and if the show will be available for streaming. These are not the kind of things that you as an actor or protagonist know early on. It is decided by the television network and the production company, and I will only get to know these things once they have told me. But rest assured guys, I will announce the launch date, title, and if the show will be available online, etc., in due time. However, that is not what I wanted to talk about in this episode. Instead, I wanted to show you my work on another television-related project that I have worked on in January 2019. Going through the process of being cast for a television show really was the first time that apparently anyone working for a German television production company even became aware of my online existence. The set designer for the show I worked on visited my shop because he wanted to recreate the style and atmosphere of my workshop on set. He watched my videos and was impressed by the many different skills I used and demonstrated in my videos. Long story short, right after finishing filming that TV show, I got myself 2 little work orders as a prop maker for a TV film that is being produced here in Cologne at the moment. Well, it's actually 2 films produced for the ARD, which is German Public Television. It's the 4th part of a series of TV crime films called Die Füchsin, which means The Vixen. It's about a former Stasi employee living in modern-day Düsseldorf. She, together with a thrift store owner and his niece, who's a computer nerd, form a ragtag bunch of misfit private investigators who solve crime cases in this city. And reminiscent of some of the contraptions made by Q in the James Bond films, helpful tech gadgets are employed in this film as well. And that is where yours truly comes into play. So here's my first order for a movie prop then. In the film, someone receives a robotic vacuum cleaner as a gift. What that person doesn't know though is that it's actually a remote-controlled spy/surveillance device equipped with a remote control and a camera. So I received this robotic vacuum cleaner here from the production company. They had already chosen that it would be this exact model, and the deadline was already very close. In other words, there was no argument about choosing another model, maybe one that is easier to modify, or maybe one that already comes with the option to be remote controlled. And because of that, I was working under pressure and chose a very direct path to solving this problem. But I bought 2 additional robotic vacuums so that I could show you guys here on YouTube more about the technology involved and maybe try to build a remote controlled surveillance robot to secure my new workshop for real. And here's what I will show you in this video. I will tear down a robotic vacuum that is very similar to the one I used for the prop, but I'm not showing the actual teardown of the original because I already kinda did that in a video a few weeks ago. Then I will show you how I actually made the prop robot and show how it's working, and after that I will look inside yet another robotic vacuum and explore its real-life potential for a mod or DIY project involving these robots. So here is the first of the used robots that I bought. I got this one from a guy in the neighborhood for only 23 euros. And the fact that the price for some of the simpler models has fallen so drastically clearly shows that they are now good material for my channel, something that certainly wasn't true just a few years ago. At first glance, the robot looks different from the one I showed before, but it is actually very similar to the Severin brand vacuum cleaner that I used for the actual prop. It is also still fully operational. I couldn't really test the other robot this way here in the shop because it's supposed to be a gift and it should look new and not all dusty and with scratches all over the place. It is interesting to observe how the robotic vacuum behaves. When it touches an obstacle with its front bumper, it seemingly just steers a few degrees to one side and then tries it again, and it repeats that until it can find a way. It usually travels in a straight line, but under certain circumstances it will start to drive around in circles. It can detect when it's picked up from the floor, and a few other things we'll talk about later. To get an impression about what it would actually look like to film a room from this perspective, I mounted my older camcorder on top of the vacuum, by the way. But let's explore what we find inside this robot then. The dust container is easily removed, something you have to do every few minutes if you run this in a dusty workshop environment. Just like in the other robot though, a brushless DC motor is driving an impeller that generates the actual vacuum.
Instead of a lithium-ion battery, we find a nickel metal hydride battery pack though, and maybe that is because this robot here is a little older than the other one.
These drive units are more or less identical to the ones I found in the Severin brand robot as well. It's a DC motor driving the wheels via a combination of a worm gear with planetary gears inside the hub. The main PCB looks different because it uses some through-hole components for the H-bridge and some other parts of the circuit. But like in the first robot, the front bumper interrupts a single light barrier in the front of the robot. For that, it uses a standard photo interrupter. 2 additional DC motors with worm gears are used to rotate the brushes underneath the robot. And here you can see the entirety of all the electronics except the battery, that is. These 3 identical parts here are optical reflection sensor units that are normally positioned in these spots here on the bottom of the robot. They consist of an infrared LED and a phototransistor, and their purpose is to protect the vacuum cleaner from falling down stairs. Light is emitted and then reflected by the floor, which is then partially falling back into the phototransistor. And there are little plastic sliders that act like kind of curtains, and they are used to adjust the sensor to different floor types with different reflective behavior. Here's a light barrier consisting of an LED and another phototransistor. I think this one is for detecting whether the intake of the vacuum is clogged or to check if the dust container is full. Then we have the BLDC, the drive units and the brush motors. This little board simply holds the on-off switch and the power supply jack. The cutoff wires here normally lead to the battery pack. The PCB itself is basically like a microcontroller board with some peripherals, including 2 H-bridges and a few power transistors. So if I find a really interesting robotic vacuum in the future, maybe then I might actually go through the hassle of reverse engineering one of these boards properly. But in this case here, we have a very cheap platform, and if you wanted to, well, reuse this robotic platform for something else, then I think it is much more economical in terms of time spent to just take an off-the-shelf microcontroller or development board and then maybe combine that with the salvaged power components from this board here, rather than actually trying to repurpose and reprogram the original PCB.
Even though I was tempted to make a low-budget hacker project out of this, I decided not to fool around with this robot, but rather just go down the most promising path. A normal person with 0 tech skills needed to be able to operate it, and the remote control needed to be very reliable. Rather smooth operation of the robot needed to be available so that the onboard video footage wouldn't be too shaky. The robot also needed to look like a normal vacuum from the outside, and it was also necessary to swap batteries quickly on set. Once the cameras are rolling, time is money, and using the internal charger and wait for an hour for the robot to come back online was out of the question. On the upside though, I didn't need to take care of the camera side of things at all, since they would simply glue a small professional camera onto the bot, much like I did in my test. So what I did was to basically strip the robot of all the standard electronics, just keeping the original battery pack, drive motors and on-off switch. Then I ordered 2 of these speed controllers / motor drivers here, and it needed to be models which would be okay with the rather high voltage of around 12 to 14 volts coming from the battery. I also bought a 2.4 GHz remote control and an external battery charger. First, I tested the speed controllers. They have 2 leads leading to the battery, 4 leads leading to the motor, of which I removed 2. I also bypassed the on-off switch. Then I connected the speed controller to the receiver. Next, I built the setup here with a bench power supply, powering the remote control and the speed controllers with roughly 12.8 volts while supplying 5 volts to the receiver, clearly showing that the robot will also need an internal step-down converter to 5 volts so that the receiver can be operated from the robot's battery. And it worked very well. It was rather easy to fine adjust the motor speed, and reversing the direction was also no problem. The remote control connected reliably and without any glitches. So what happened next is that, reusing the original battery pack and power switch, I connected two of these speed controllers to the two motors, added a 5-volt linear regulator and connected the receiver on board as well. I decided to use the old dust compartment to install the new electronics. This way they would be easier to service if needed. And the first test worked out pretty well, even though my driving skills were still pretty poor. After the first successful test, I shortened all the wires and glued everything in place with MS polymer. Not exactly a beautiful solution, but remember, this thing has to do its job for just 1 or 2 days, and that's really all that counts here. The robot could now be steered with differential steering, and the way you handle the remote control is much like with a tank. And after just a few minutes of training, I could obtain almost perfect control over it. To my amazement, the robot turned out to be stronger than I expected as well. Following the wishes of the production team, a few finishing touches were added as well. They wanted a green LED, so they got one. Just a few days before filming began, it was decided that the robot wasn't supposed to look completely normal after all, and it was decided that a miniature camera should be added to the enclosure. It was just a prop though, and without functionality. The thought here was that the viewer was supposed to understand how this thing can film someone. And as far as I know, the woman that plays the computer hacker in this film is supposed to do something on camera showing that she is actually modifying this robot, and apparently gluing the fake camera to the vacuum cleaner was supposed to display that. But with the robot finished, my work wasn't done yet. I had bought this battery charger and replacement batteries for the robot, and I also had made an adapter cable for these batteries. But then I realized that charging the batteries without clear instructions might be too complicated for the people on set. They are under immense pressure, and there is no time to go through some manual. So I filmed short explanation videos for everything from setting up the charger to charging the batteries to using the remote control. And long story short, the robot was used for filming last week and it worked perfectly, and I actually got a call there where they thanked me also especially for making those instruction videos, which made its use much easier for them. So in other words, it appears that this was the right solution for this job. And if you want to see it in action, watch Die Füchsin Part 4, where my first ever prop will then appear. I will let you guys know once they tell me the broadcasting date, of course. But while doing this job, I also realized that apart from this fictional setting, there could actually be real uses for used vacuum robots, and I'm now kind of fascinated with the idea of repurposing them, and that's why I actually bought another robotic vacuum, this time for around 30 euros, from yet another guy here in Cologne. So let us do another quick teardown then and compare this robot, which must have been of a slightly higher price category, to the two other cheaper models. By the way, it doesn't work anymore, and I think that's just because one or more motors are stuck. This time the battery pack consists of 12 nickel metal hydride cells. That means that the nominal voltage would be 14.4 volts. When fully charged, we might see voltages in excess of 19 volts though, and that means, for example, that this battery would have been too high in voltage for the RC speed controllers we used in the RC conversion with the other robots. It is also apparent that this model has two big brushes on the bottom that the other two models didn't have at all. After opening the enclosure, I can also see that the front bumper has not one but two photo interrupters, one on the left and one on the right side, which would probably give the robot more accurate information about the location of an obstacle it just ran into. The main PCB has a larger microcontroller, but as it seems less power electronic components. On the bottom I can find 4 of those optical stare sensors again I talked about earlier. But in addition to these sensors, all the 3 wheels have little switches that are all connected in parallel. So once 1 or more wheels have no contact to the ground, there will be a conductive path between those 2 wires. The robot will definitely be able to tell when it's picked up from the ground, but this could probably also help with avoiding falling down stairs or similar dangers, I guess. Not sure what happens though, as I can't test the robot. Once you turn it on, it goes into a kind of error mode after just a few seconds. The motor for these large brushes appears to run without much effort. But about the drive motors though, I'm not that sure. First of all, I have to mention that I think it's pretty cool how they added a primitive suspension to the drivetrain. It's cheap but effective and feels much more robust than what we saw in the other robots. The motors run, but they seem to draw a lot of current for having no real mechanical load on them, and they also sound kinda as if they're struggling a little bit. Inside of the drive units we find a brushed DC motor with a metal pulley driving a toothed belt that then in turn is connected to planetary gears inside the hubs. In addition to that, the drive units also have optical rotary encoders, which is pretty awesome, and we'll take a closer look at those in just a minute. But first, the wheels have to be cleaned. The reason why the motors struggle so much, and potentially the reason for the robot being faulty, is that tons of hairs are stuck in the mechanical parts, making it extremely hard to turn the wheels. And this is nothing for the faint of heart. I take all that nasty stuff out of there, but it's also a pretty important lesson about something that any household robot will have to deal with. It's not easy to build something like this and not have hairs and other dirt being introduced into the system. After removing the hair, it seems to work better. But let's get back to those rotary encoders. Now you might have seen this before in inkjet printers, for example. The encoders consist of a light barrier made from an infrared LED and a phototransistor. And in addition to that, you have an encoder disk that periodically interrupts the barrier, sending pulses, the frequency of which is proportional to the rotational frequency or speed of the wheels. It allows you to operate the wheels in a closed feedback loop, which is pretty useful, especially in a robot. And after adding a few parts, I can show you what this feedback signal looks like in an experimental setup. But what parts do you need to get this running, and what is it actually good for? Well, I'll explain that in the next video about these robots, in which I will show some actual repurposing ideas. For now, I just wanted to show the prop making and give you some more insight into the technology involved. But before I go, let me show you another prop that I had to make for the same exact film. See, in this film, there is apparently another James Bond-esque scene where someone's phone lines are cut. Or rather, the protagonists try to cut someone's phone line, but they don't know which exact wire they need to cut, so they just decide to cut through the biggest wire they can find, potentially disrupting the telephone lines of the entire block or whatever. So the production company brought this box here to my shop
In Germany it's called Verzweigerkasten, and this is what the German Postal Service has installed for decades at every other street corner. Problem is, it's completely empty. So my job was to install a large number of wires in there so that the viewer would understand right away that what we're talking about is a very complex system that no outsider would understand just by looking at it. But then there would be one thick wire or bundle of wires optically standing out from all the others, and that's what the actors will cut on camera. So the first challenge was to find the right kind of clamps to use inside an installation like this. I was able to find this one package of new old stock parts that were, I guess, actually used by telephone companies back in the day. But I just couldn't get enough of them to fill this box. So what I ended up using are parts that I had salvaged from the trash many years ago when a nearby railroad line was demolished. It's not exactly what they seem to have used for telephone lines, but it's close enough, I guess. So I installed this black enclosure here inside the box, the purpose of which I will show you in just a minute. And then I installed those clamps inside the box. Next, I bought actual telephone wire and started to make hundreds of random connections, which still took me almost the entire day. Last but not least, I made 6 or so fake wires from CAD cable. These fake wires would be the ones to be cut in the film. But another requirement was that they needed to be easily exchangeable so that the actors would potentially have 5 or more tries or takes cutting the line. So this prop was also already used for filming and the production company seemed to be very satisfied with it. But for me, this was a weird experience since I had to follow some requirements that seemed nonsensical to me. For example, that the orange wire had to leave the box in the upper left corner rather than going back into the ground. But this is just what it seems to be like when you work for the movie industry. And frankly, as long as average Joe, who also doesn't work for the telephone service provider, buys it, then I guess it's good enough. So guys, I know this video covered a lot of different things, but that's just what my January was like. All these projects, including the filming and editing, happened while also moving into the new workshop, which will still go on for a few more weeks until everything is just right. Once that has happened, things will become more structured again. But I still hope that you like this video, and if yes, then please give it a like. And maybe also check out my Patreon if you want to support this channel. See you soon.